6 wheels sit under the front end of the locomotive. 4 of them have a motor bolted in beside the axle. The middle one has nothing next to it at all. It just rolls. That axle is not broken, and it was never meant to be fixed. General Electric built it that way on purpose, sold more than 1,100 locomotives with it, and told the industry it would end an entire class of machine. Union Pacific looked at the same locomotive and bought none. Have you ever been handed a machine somebody else picked out for you and found out on the job what it could not do? Put it in the comments. This is what American Iron Works takes apart. Subscribe so you catch the next one. To understand why 2 railroads split over 1 wheel, you have to know what a diesel locomotive actually is. It is not a diesel machine the way a truck is. The engine in the middle never touches the wheels. It spins a generator. The generator makes electricity, and that electricity runs motors mounted down on the axles. Those motors do all the pulling. So every one of these things is an electric locomotive carrying its own power station. By 2009, there were 2 kinds of motor a builder could hang on an axle. Direct current motors were cheap, simple, and a century old. They also cooked themselves if you made them strain at a crawl for too long. Alternating current motors cost far more, because each one needs an inverter feeding it the right kind of power. What you got back was a motor you could stall dead under a loaded train, and it would sit there and take it. Railroads wanted alternating current. Very few of them wanted to pay for it. General Electric had been chasing away around that problem for most of a decade. As early as 2001, the company walked a 5-axle concept into BNSF for evaluation. BNSF looked at it and said no. So the builder went back and tried the same idea a different way. The answer it landed on was a subtraction. Its engineers took the 6-motor AC locomotive already in the catalog, the ES44AC, and pulled the middle traction motor out of each truck. 4 motors instead of 6. 2 fewer inverters. A cheaper machine that still had the AC behavior railroads were chasing. Count the axles front to back and you get 1, 3, 4, and 6 doing the work. 2 and 5 turn because the rail makes them. That arrangement has a name in the Association of American Railroads Code. A1A. Powered, dead, powered. No American builder had put an A1A truck under a mainline diesel since the late 1950s. This was the first one in 50 years and the first ever built with AC traction. What I keep coming back to is that the locomotive left the design stage finished, and then somebody deliberately removed working parts from it before it shipped. That decision needed a fix, because 4 axles gripping the rail is less grip than 6. So General Electric patented 1. Air cylinders mounted on the truck frames lift the dead axle slightly off the rail at low speed. When it comes up, the weight it was carrying drops onto the 4 powered axles. They press harder into the steel. They bite. When the train picks up speed and stops needing the help, the axle settles back down. Very little actual lift is involved. This is not a wheel swinging in the air. It is a few thousand pounds of load being shifted sideways across a truck frame by compressed air while a loaded freight train is moving. The company called it dynamic weight management. At the rollout on May 18, 2009, General Electric said the system would be redistributing weight for less than 5% of the locomotive's total operating time. 5%. For the other 95%, that axle is dead weight, rolling along behind 2 powered wheels. Lorenzo Simonelli was president and chief executive of GE Transportation, and he stood at that rollout and made a prediction on the record. This locomotive, he said, could simply mark the end of DC power in North America, period. The sales case underneath that claim was strong. Graciela Trillanes, the product manager for the machine, put the fuel saving at up to 17% against a 30-year-old 3,000 horsepower DC unit, with emissions down about 70%. BNSF Railway believed all of it. The railroad took 25 pre-production units in 2009, numbered 6600 through 6624, and ran them through testing before committing to anything. The results came back strong enough that BNSF started ordering by the hundred and did not stop for 11 years. Florida East Coast bought 24 in 2014. That was the entire customer list. Every other Class 1 railroad in North America got handed the same catalog and passed on it. When Tier 4 emissions rules landed in 2015 and the model was rebuilt as ET44C4, BNSF kept buying. More than 200 of those followed. The locomotive worked. It hauled intermodal across the Southwest for 11 years, and if you watched a train roll by in Arizona in 2016, there was a strong chance the orange machine on the point had 2 axles doing nothing. But there was a number sitting in General Electric's own specification sheet from the first day, and almost nobody put it next to the right locomotive. Tractive effort is the measurement that matters here. It is the pulling force at the wheel, and the number railroads care about most is continuous tractive effort, which is what the machine can hold indefinitely at low speed without damage. The 6-motor ES44C produces 166,000 pounds of continuous tractive effort. Strip 2 motors off it, and you get the ES44C4, which produces 105,000. That is a gap of 61,000 pounds. A 37% cut in the exact measurement that governs dragging a heavy train up a grade at walking pace. Starting tractive effort tells the same story with a smaller gap. The 6-motor machine breaks a train loose with 183,000 pounds. The 4-motor version manages 144,000. When the Tier 4 generation arrived, the 6-motor ET44C4 AC climbed to 200,000 pounds of starting effort. The 4-motor ET44C4 did not move at all. It stayed at 144,000 and 105,000, exactly where it started in 2009. 61,000 pounds is roughly the weight of 2 loaded semi-trailers. That is what came out of the locomotive's low-speed pulling power permanently the moment those 2 motors were left on the shop floor. And it came out of the exact condition the axle lifting system exists to rescue. That number doesn't fit the story most people tell about this locomotive. Which surprises you more, that the gap was that wide, or that it sat in a public spec sheet for over a decade? Now there is a defense, and it is a real one. General Electric never claimed the 4-motor machine matched the 6-motor machine. It claimed the 4-motor machine matched the old 6-axle DC units it was built to replace. On that comparison, it delivered. DC road switcher production in North America did end. That comparison is the thing that bothers me. It was the flattering one, and it was the one everybody used. Because the fleet was not being bought to replace DC locomotives forever. It was being bought as general-purpose power on a railroad that also crosses mountains. Watch what the design actually optimizes for. 4 powered axles are enough when a train is moving fast on flat, straight track, because at speed, it is horsepower that sets the pace, not grip. The 2 extra motors on a 6-motor unit are mostly along for the ride out there. So the savings are real on hot intermodal running across the Southwest. But AC traction's entire advantage over DC is what it does at a crawl. That is the whole reason the technology cost more. So General Electric built a locomotive that saved its money in the one service where AC traction matters least. The flaw was not a mistake somebody made. The flaw was the economy itself. You cannot remove the 2 motors without removing the pulling force they produced, and no air cylinder put 61,000 pounds back. Electromotive Diesel watched all of this and wanted in. The company had been building American locomotives since the 1930s. By 2012, it was owned by Caterpillar, working out of a plant in Muncie, Indiana, and it was losing ground to General Electric badly. So it copied the idea, with one change. Where GE killed the middle axle of each truck, EMD killed the 2 axles nearest the fuel tank. The code for that is B1-1B. Same economy, different geometry, and you cannot tell the difference from a road crossing. BNSF took 20 of them in 2014. That was the entire market. Not 20 as a first order. 20 total forever. 2 demonstrator units went out on lease to a short line in Washington State and were eventually sold off to a railroad in Arkansas in 2023. Trains magazine gave the design a 2-word verdict: a bust. The same subtraction printed money for one builder and humiliated the other, and the engineering was not the difference. There is one more thing about that dead axle, and it is the detail that changed how I read this whole story. The A1A arrangement was not invented in 2009. It came into American practice in the 1930s and 1940s, and builders used it constantly. Alco cataloged the RSC2 and then the RSC3. Baldwin ran a whole road switcher line on the same trucks, and Montreal Locomotive Works built them north of the border for Canadian National. They all had a dead middle axle, and they all had it for the opposite reason. Those locomotives were built for branch lines. Secondary track, laid with rail weighing under 100 pounds per yard, crossing timber bridges that were old when the diesels arrived. A 4-axle locomotive concentrated too much weight on each axle, and the track could not take it. So builders added a 6th wheel with no motor on it, purely to spread the machine's weight across more steel. The Alco RSC3 got axle loading down to roughly 41,667 pounds per axle. That was the whole point. A1A existed to reduce the load each wheel put on the rail. In 2009, General Electric revived the identical wheel arrangement to do the exact reverse. To lift a wheel off the rail, to take weight off one axle and pile it onto 4, to increase axle loading deliberately at the moment grip runs out. Same 6 wheels, same code in the same rulebook. Opposite purpose, 70 years apart. And the moment you see that, the air cylinders stop looking clever and start looking like an argument the builder was having with its own hardware. Union Pacific spent those same years answering the same problem, and it went the other direction entirely. The railroad kept 6 motors on everything and then made the locomotives heavier. Its SD70AH units weigh 427,000 pounds. They carry rail conditioners, air jets that blow the railhead clean just ahead of the wheels. They carry tractive motor control and cruise control. Mass, grip, and no moving part anywhere in the traction path. BNSF bought software and an air cylinder. Union Pacific bought weight. Now, here is where the record goes quiet, and it is worth being honest about it. Union Pacific never bought a 4-motor 6-axle road locomotive from either builder. Not one from GE or EMD across 11 years of production. But the railroad has never publicly said why. There is no press release, no executive statement, no engineering paper explaining the objection. Union Pacific appears in this entire story only as an absence, and everything anybody knows about the refusal is inferred from what it bought instead. 11 years of production, 2 builders, roughly 1,140 machines delivered to 2 customers. And on the other side of the ledger, one of the largest railroads in America saying nothing at all. BNSF stopped too. The last C4 locomotive was delivered in 2020. In 2023 and 2024, the railroad's new orders came back as ET44C4 and ES44C4 units. 6 motors, every axle powered. Ballasted to 436,320 pounds, which is heavier than anything it had ordered before. BNSF ended up in exactly the position Union Pacific had held the entire time. A program that big does not just stop, something ends it. And what makes this case strange is that nothing did, at least not publicly. No railroad published a failure report, no regulator issued a finding, no derailment got traced back to an axle that did not lift. There is a forum thread from 2023 where somebody writes that the C4 issues finally seem to have sunk in, and that is the closest thing to a public reckoning this locomotive ever received. Search the trade press and you will find the design's beginning covered in detail and its ending covered in a single sentence. So the honest version of this story is not that the 4-motor locomotive failed. It is that it stopped being ordered quietly by the only railroad that ever wanted it, which then spent money going back to the arrangement it had left. Lorenzo Simonelli said in 2009 that this machine would mark the end of DC power in North America. He was right about that. DC road power did end. What ended alongside it was his own locomotive. And the reason sits in the one sentence that describes the whole design. General Electric removed 2 traction motors to make an AC locomotive affordable, and removing those two motors is what took 61,000 pounds of pulling force out of it. The saving and the weakness are the same act. There was never a version of this machine that had one without the other. That is the shape worth carrying out of this. When a company engineers a cost out of a product, the cost does not disappear. It moves. It lands on whoever is holding the controls when the grip runs out, on a wet grade, at 3 in the morning, with no say in what showed up on the point that night. This is what American Ironworks does with the machines everybody else just films going past. Subscribe so you catch the next one.